Good day to our beloved students. Welcome to our math class. It's a great pleasure for me to teach you and give you the learnings needed for our today's lesson. Our objective is to solve equations involving radical expressions without extraneous roots. Are you ready to further understand the lesson? Okay, let's begin. Our lesson is all about solving equations involving radical expressions without extraneous roots. In our past lessons, we have already learned about radical expressions and operations involving radical expressions. Now, in this lesson, we're going to another level. We are now going to learn how to solve equations involving radical expressions. What do we call equations involving radical expressions? These equations are called radical equation. Radical equation is an equation containing radical with variables in the radicand. Examples of these are square root of a plus 5 is equal to 3, square root of r minus 1 is equal to 4, and square root of 3t plus 2 is equals to 5. How do we solve radical equations? Together, let us learn the steps on solving radical equation. On our first example, we have square root of a plus 5 is equals to 3. To solve the given problem, first, we square both sides of the equation. Thus, we have a plus 5 is equals to 9. Then we add negative 5 to both sides of the equation to eliminate the constant term 5 on the left side of the equation. Solving, we have a is equals to 4. Now, we already determined the solution on the given problem. To check if our answer is correct, we use the value of a and substitute its value to the equation. Thus, we have square root of 4 plus 5 is equals to 3, or square root of 9 is equals to 3. Solving for the square root of 9, we have 3 is equals to 3. Since the left side and the right side of the equation is equal to each other, therefore, we have a correct solution. Next example, we have square root of 3t plus 2 is equals to 5. To solve, first, we add negative 2 to both sides of the equation to eliminate the constant term 2 on the left side of the equation. Thus, we have 3t is equals to 3. Then, we square both sides of the equation. This results to 3t is equals to 9. Next, we divide both sides of the equation by 3 to eliminate the numerical coefficient, which is 3. Solving, we have t is equals to 3. Checking our answer, we substitute the value of t to the original equation. Thus, we have square root of 3 times 3 added to 2 is equals to 5. Then, we simplify the radical and extract its square root. This results to 3 plus 2 is equals to 5. Solving the equation, we have 5 is equals to 5. As I have said, since the left side and the right side of the equation is equals, therefore, t is equals to 3 is a correct solution. For our third example, we have 2 square root of 3t added to 2 is equals to square root of 3t added to 5. To solve the given problem, we add negative square root of 3t on the left side and negative 2 on the right side of the equation. This results to square root of 3t is equals to 3. Then, we square both sides of the equation, resulting to 3t is equals to 9. Next, we divide both sides of the equation by 3, since 3 is the numerical coefficient of t. Solving, we have t is equals 3. To check our solution, we substitute the value of t to the original equation. Substituting the value of t, we have 2 square root of 3 times 3 added to 2 is equals to square root of 3 times 3 added to 5. Then we simplify the radical on both sides of the equation and get its square roots. This results to 2 times 3 plus 2 is equals to 3 plus 5. Solving both sides of the equation, we have 8 is equals to 8. Since the left side and the right side of the equation is equal, therefore, we have a correct solution. For our last but not the least example, we have 3 square root of 3x decreased by 1 is equals to 2. To solve this problem, we add 1 to both sides of the equation. This results to 3 square root of 3x is equals to 3. Then, we divide both sides of the equation by 3 to isolate the radical on one side of the equation. Solving, we have square root of 3x is equals to 1. Next, we square both sides of the equation. Thus, we have 3x is equals to 1. Then, we divide both sides of the equation by 3, since 3 is the numerical coefficient of x. Doing so, we have x is equals to 1 over 3. So those are the examples on how to solve radical equations. To sum up our lesson, remember that radical equation is an equation containing radical with variables in the radicand. Also remember the following step in solving radical equation. First, isolate the radical expression in one side of the equation. Then, square both sides of the equation. Next, we combine like terms. Then, if a radical still remains, repeat step 1 to 3. After that, we solve for the variable. And last but not the least, check the resulting value of the variable in the original equation. So that ends our lesson on how to solve equation involving radical expression without extraneous roots. I hope that you enjoy and understand the lesson that we have discussed clearly. If not, you may go back to the lesson presented. If the lesson is clear to you, congratulations! You may now proceed in answering the exercises given to you in your module. Again, this is Mr. Herbert Evangelista saying good luck, God bless, and enjoy learning. See ya!